Hi everyone. So another skills video. This time on M1 Suvat, which you may be doing quite a lot in physics on, but not everyone does physics, and also kind of maths has always done Suvat in a slightly different way. So if we start this off, there are 5 different Suvat equations, and also we need to define what Suvat actually means. So some people may not even know what Suvat means. So Suvat, the S, U, V, A, T all stands for certain things. So the S does not stand for distance. That's often a mistake. It stands for displacement. Now, what is displacement? Well, displacement is rather than how much distance is traveled. So let's say I've got this point A here and this point B here, and these are 5 meters away, right? So let's say I'm a particle zooming around, blah, 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 doing all this crazy stuff, and then I end up back at B. What's the displacement between at this point when I started and when I finished? Well, the displacement is 5 meters. Even though I've traveled, let's say 1,000 meters, it's completely irrelevant. The displacement is literally where you are, where you finish relative to your starting point. Okay? U is your initial velocity, and V is your final velocity in that section of time that you are referring to. A is obviously your acceleration, and you can't see it, so we put the T here. T is time in seconds, and yes, your displacement is normally in meters, and therefore U and V would be in meters per second normally. Okay. So what we have here is a VT graph, so a velocity time graph. So on the y-axis, this will be your velocity, and like I say, your unit is meters per second. And also on the x-axis, this is your time in seconds, right? So seconds and meters per second. Okay, so velocity time graph, obviously velocity is not speed. Velocity is speed with direction. It's a vector quantity. Okay, that's important to remember because velocity therefore can have a direction. Now, Suvat assumes constant acceleration. Now, remember I said u was the initial velocity. So here, time is 0. Here's u, our initial velocity. And this top point here, well, this is where we end. So if this is time t up to this point, we've got v, which is our final velocity value. Okay? And from here, we can start to derive all of the Suvat equations. So, Suvat equation 1. Well, let's look at it. We know that the gradient of a straight line is change in y over change in x, and the gradient is the rate of change. So the rate of change of velocity, so as velocity changes per second, i.e. the change of velocity over change in time, dv over dt, that is acceleration, isn't it? The steepness of the curve is the acceleration, how quickly this thing is increasing in velocity. So A is change in y. So here, remember, we've got our x value is t and our y value is v. And at this point, we've got our x value of t is 0 and our y value of u. So A is going to equal v minus u over t take 0. So therefore, you can rearrange times up by t. You get at equals v take u, and therefore v equals u plus at. That's equation 1. Fantastic. Equation 2. What else can we get from this? Well, we know that distance equals speed times time. Now, if you think about it, the displacement then, this is going to have positive displacement always because the velocity is increasing all the time. Therefore, speed equals distance equals speed times time, it's going to equate then to the area beneath this curve. So this is you haven't met this yet, but how we would move in M2 is you would have displacement to velocity to acceleration, and remember velocity is rate of change of displacement over change in time. So this would be, we haven't learned it yet, but through differentiation. And then velocity, as we've said, is the rate of change of velocity, so that would be differentiation. And to go backwards would be integration. So if you wanted to find the velocity from the acceleration, you would integrate everything, and integrate essentially would be to find the area beneath the curve. These are all things you haven't met yet, but I'm just introducing them to you. So number 2, the area beneath that curve will represent the displacement. Now that is a trapezium. You can see this shape is a trapezium. What's the formula for the area of a trapezium? Well, S is your displacement there, so S is the area. You have your 2 parallel side lengths added together. That's the formula for an area of a trapezium. So you've got U plus V, there's your 2 parallel sides added up together, divided by 2, in other words, take the average, times by the width, and the width is T. So there we go. There's our second equation. Okay. Number 3, how do we get the other ones? Well, we don't actually need to use the graph anymore. We can just use 1 and 2, to be honest, but we could use the graph. But let's just try and get up some practicing on our algebra. Okay, so notice this first one doesn't have S in it, this second one doesn't have A in it, the third one we're going to have not have V in it, etc. It doesn't really matter what order we pick. So, if I want to come up with this third one, I could say that S equals U plus V. So V, we know, is U plus AT. We just derived it here. So U plus V, which is U plus AT, all over 2 times by T. So that is U plus U, that's 2U, plus AT over 2 times T. So 2U over 2 plus AT over 2 all times T, all times T, and we're starting to get the picture. So this will end up with equals UT plus half AT squared. So there we go, there's number 3. Likewise, number 4 and 5 can be made in the same way, and I think I'll get you to carry that on by yourself. So pause the tape and make them by yourself. You're trying to construct V squared is U squared plus 2AS, and also S equals VT minus half AT squared. Okay? These are your 5 equations. Now, how do we use them? Well, let's have a go through an example. So a particle P is moving on the x-axis, and it's always helpful to draw a diagram. Particle P is moving on the x-axis with constant deceleration 2.5 meters per second squared. So let's say it was traveling this way. It's decelerating, so on my picture, notice the double arrows for acceleration, a single arrow for velocity, so 2.5 meters per second squared. At time t equals 0, the particle passes through the origin O, so here's the origin O, moving in the positive direction with speed 15 meters per second. So U is 15 meters per second that way, as my picture describes. Okay. Find the time, so part A says find the time between the instant when P first passes through O and the instant when it returns to O. Well, so we'll generate our, all Suvat problems will start this way, and we're talking about something which is traveling to the right, yeah, on our line. So I'll always put direction to the side. S is the displacement. Let's think about it. So this particle is going with 15 meters per second this way, but it's also decelerating. So it's slowing down, slowing down, slowing down, slowing down, slowing down until it stops. And then it starts traveling back to where it came from, right? So remember what the definition of displacement is. If we're looking for the time that it takes for this thing to return to O, then even though it's traveled all this way across here, it doesn't matter. Where's its start and finish point? That's what we care about. It's at the origin. So U was 13, V, don't know what V is, so I'll just write V. The acceleration or deceleration was minus 2.5 because it's relative to that direction. T is the time we're trying to find. So, don't care about V, that's not what I'm trying to find, I'm trying to find T. So we go to our Suvat equation, S equals ut plus half at squared. Therefore 0 equals 13t plus a half, our A was minus 2.5 t squared. So from here you can use your silver calculators to solve this. And when you do, you get t equals 10.4 seconds and t equals 0 seconds, which makes sense because t equals 0 was when time started, and when we started the time, that's when we were at the origin. So we need to wait for the particle to come back to the origin. So find the time between the instant when P first passes through O and the instant when it returns to O. Well, the time was 10.4 seconds. Okay. Part B then. Find the total distance traveled by P during this time. So let's think about that. I told you that this thing's speed slows down until it stops. We need to know the distance it takes for this thing until it stops, and then we'll double it because it's traveled that way and then it comes back. So if we go for our Suvat again, always the same. It always helps if you just write your Suvat down and then you can see what you have. S is the distance we're looking for, so don't know. U, we know, started at 13. V, don't know. I don't know. Oh yeah, but actually I do know the velocity, and that's the whole point of this question. By the time this thing slows down and stops, if it stops, it's not moving, so the velocity is 0. The acceleration is still minus 2.5, and we've got our time t again. Okay, and we actually know what the time t is though. We know the time was 10.4 in order for it to get back, but let's just assume we don't know what it is. You know, we can't assume necessarily that it's going to be half that. So let's carry on with what we have. Okay, so we're trying to find this s, so we don't care about t actually. So we got v squared equals u squared plus 2as, that's our Suvat equation. We've got v squared is 0, so 0. 13 squared is 169, plus 2 lots of minus 2.5 s. And therefore I can rearrange to get s equals 169 over 2 lots of 2.5, just a bit of rearranging, and that whole thing, let's just rewrite that, to 2.5. And that whole thing is going to equal 33.8 meters. But remember, it's saying what's the total distance traveled. So we're going to put total distance equals 2 times 33.8, which is 67.6 meters. And we're done. Okay. Next example, let's try again. A ball is projected vertically upwards from a point X, which is 5 meters above the ground. So, always helpful to draw diagrams. So, point X, which is 5 meters here, so there's X, and that's 5 meters. Okay, and it's being projected upwards with initial speed 21 meters per second. Part A says find the greatest height above the ground reached by the ball. So let's think about it. The ball goes up and then it stops, doesn't it? And then it starts coming back down again. So it is in a straight line though. It is up, down, but for artistic license, I'm going to draw it like that. So find the greatest height. So again, this time our direction's up and down because our initial motion is going up. So everything is relative to up. S is, don't know. U started at 21. Velocity at the top, greatest height must be 0 before it starts changing direction. Acceleration, well, we're fighting against gravity. And gravity acts at our minus 9.8 per second squared. T is our time. Trying to find the greatest height. Don't care about t then. So we're going to use our v squared equals u squared plus 2as formula. V squared is 0, u squared is 21 squared, plus 2 lots of minus 9.8 times s, and s equals 22.5 meters. But it asks for the greatest height above the ground, so above ground equals 22.5 plus 5 meters, which is 27.5 meters. And this is 3SF because we worked with G. And remember, if we're working with G, that's 2SF, so the maximum we can give our answer to is 3SF. We've also got to find the total time of the flight of the ball. So let's think about it. Let's be smart, right? So none of this kind of splitting it into two sections. One Suvat table to rule them all. That's all we need. So we started here. When we finish, we're down here. So it doesn't matter that we've gone up, down, left, right. It doesn't matter. All we care about is our starting point and our finishing point. And our finishing point is down there. So relative to the upwards direction, it's minus 5. It's 5 down, isn't it? Started at 21 up. V, don't know. Minus 9.8 because we're fighting against gravity. T, don't know. We're trying to find the time of the flight. So we get rid of V. S equals ut plus half at squared. So therefore, minus 5 equals 21t plus a half minus 9.8 t squared. Again, if you move it all over, so half minus 9.8 t squared plus 21t plus 5 equals 0. You can solve this using your silver calculator, and you get 4.51 and minus 0.226, etc., which you'd expect. So that's Na. So this one must be our solution. T equals 4.51 seconds to 3SF. You must state how many significant figures, and it must be maximum 3. Okay? That's your total time of flight. Finally then, last example. At time, this is much harder. At time t equals 0, two balls A and B are projected vertically upwards. So let's draw a graph again. Point A is projected with 2 meters per second from a point 50 meters above. So 50 meters here. Here's a point A projected with 2 meters per second, whereas particle B is projected from the floor with 20 meters per second. It's saying at the time t equals big T seconds, the two balls are at the same vertical height h from the ground. So somewhere up here, h meters, these two things meet in the middle. Well, that makes sense, doesn't it? Because this is moving faster than this one. Okay. Part A, find the value of t, and part B, find the value of h. Okay. So all we can do for this is generate Suvat tables for both A and B. So S equals U equals V equals A equals T equals S equals U equals V equals A equals T equals. We have for A, let's think about it. The displacement for A, when these two things meet the same height at the same time. So that gives us T straight away. They both fighting against gravity. We don't know the final velocity for either, and for A, we know it starts at 2, and we know this one starts at 20. Now we've got this idea of S. So it's obvious for B, because the total displacement is a movement up by h meters. But for part A, it started 50 meters up. So actually the distance it's traveled is, well, not distance it's traveled, sorry, its displacement is actually h minus 50. H minus 50 here. Can you see the total thing's h, take away this 50, and its displacement is h minus 50. And now you can do a simultaneous equation involving Suvat. So for A, don't care about V, don't care about V for B, S equals ut plus half at squared. So therefore h minus 50 equals 2 big T plus half minus 9.8 big T squared. Here for B, you've got h equals 20 big T plus half minus 9.8 big T squared. And now you can simultaneously solve these two things, can't you? You've got two variables, h and big T. So h equals and big T equals. I'm going to leave that now to you. And we're done.